potassium into places that are more concentrated with
Uh-huh.
potassium in them. Then they pump the electrolytes into like other concentrated places, like whatever. But like, what is it like?
I'm gonna explain it. I'm gonna explain it. I
no,
think
like, no, like, can I just get like a definition? Or,
it is an electrochemical gradient is a gradient that is established where both the concentration and the buildup of charge influence the net movement of the ions. So, to give you an example, potassium is going to begin diffusing towards this side. And as potassium leaves, this side is going to start to become more and more negative. So eventually you're going to reach a point where as potassium leaves, it's actually pulled back in because it's attracted to the negative side. So the point at which the rate of potassium leaving is canceled out by potassium being pulled back in because of the negative charge, that's equilibrium when we're talking about an electrochemical gradient.
what was the thing? Because like in the textbook it was talking about like pumps and stuff.
Yeah, so,
Like, yeah.
right, so in the neuron, the pump is just making the outside more positive and the inside less positive. So potassium is gonna, more potassium is in here, and potassium is gonna naturally diffuse out from a high concentration to a low concentration. But what we would end up seeing is that if too much potassium leaves, what ends up happening is that potassium starts getting sucked back in because of the negative charge that builds up inside the cell. But the neuron never becomes that negative. The neuron stays at -70. Potassium would start getting sucked back in if the neuron got to -92, which is the number that I think they give you in the book. The reason the neuron never gets that negative and starts sucking potassium back in, which could be bad, is because the inside stays -70 because you do have some sodium, very, very low levels of sodium coming in. So that's going to prevent the inside from getting any more negative than -70 unless the cell opens up voltage-gated potassium channels and you have potassium flooding out, then it could hyperpolarize.
Okay.
Yeah.
So like, why is the inside look so negative if the potassium is still positive?
Because it's negative relative to another side. The other side has a more positive charge. The inside has a less positive charge. So just for the sake of, just to make it easier to talk about the difference between both sides, if we were to say that the outside is 0, that would mean that the inside is -70. What this really means is that if you compare the two charges, the charge on the inside is 70 less than the charge on the outside. So it's just whoever designed the concept of the action potential said that we're going to say that resting is -70.
Wait, if sodium and potassium are